Good morning. Happy Monday. Hope everybody had a good weekend. Here's your warm up for math for today. Again, you want to copy all this down. You want to press pause. You want to go do as much as you can. If you get stuck, come back, press play again, get those hints. And if not, or when you're done, come back and see how you did. Okay? Just in case you can't read my writing, this says, what is this called? That's that number. And what are these called? This number 11 and number 13. There's a name for those numbers. Again, this is the answer to a multiplication problem. This is the answer to addition problems. Okay. Make sure you see there's a decimal in all these exponents we're doing today. Okay. And you're going to both use the generic rectangle and the standard algorithm on these multiplication problems. And remember, if there's 3 digits, that means I'm going to have 3 numbers along the top or whatever side, right? So I'm going to have 300 there. What goes here? That's the 20. And that 4 is 4 ones, right? Here I have the 60 and the 7. And don't freak out when you see in the book that sometimes they'll put like a plus there, right? Because this is really 300 plus 20 plus 4. They sort of sneak it in there. Maybe even in a test or something. It's kind of crazy. So just want to warn you about that. And don't get too worried when you see decimals, right? Hey, this 4 is 4 what? Oh, that's 4 ones. That 2 is what? That's 2 tenths. And that 3 is 3 hundredths. All right. Yeah, you're just gonna write it like this, okay? All right, go ahead and try these. Okay, and see how you do, and then come back and check. And you will either be patting yourself on the back saying good job, or you'll be saying, ha, I learned something. Either way, win-win, right? Okay, see you in a while. Okay, amazingly fast. I'm back with the red pen now for the answers. What 2 numbers multiplied together have a product of 42 and have a sum of 13? Well, 6 and 7. How about a product of 28 and the sum of 11? 7 and 4. What if you said 4 and 7? Well, since 7 times 4 is the same as 4 times 7, and 7 plus 4 is the same as 4 plus 7, that works too. Same thing, right? What's the word that describes that in math? Commutative. Commutative. All right. 1 and 8 tenths and 3 and 6 tenths. Wow, I just realized this is half of that. That's kind of weird. Anyway, what works there? Well, what times what equals 18? I got 2 and 9. I got 3 and 6. Ooh, 3 and 6. 3 times 6 is 18, but I'm going to move the decimal over 1 spot, so I'm going to move it over 1 spot here, so I get the 6 in the tenths place and the 3 in the ones place. Same idea here. 6 and 3. This time the 3 is in the tenths place. Tricky, huh? Some of you guys, oh man, I gave up on that too soon. I probably could have figured that out. All right, 3 times 3. Remember the number 1 rule when you multiply decimals is pretend there's no decimal. So I'll go with 3 times 3 is 9. 4 times 4 is 16. I'm going to go ahead and do all these. 5 squared is 25. 6 squared, 36. 7 squared is 49. Go ahead and say this out loud, right? 16 times 16, right? 16 squared. Say 9 squared and 8 squared. You get used to using that word and you will feel comfortable using that word. 1 to the second power is 1 times 1. It's not 2, it's 1. 1 times 1 times 1 is not 3, it's 1. 1 to any power is 1, right? But remember, what I did here was 3 tenths times 3 tenths. And in order to pretend that 3 tenths was an actual 3, I had to move the decimal over to the right 1 spot, remember? Right, $3 is the same as $3.00. So if I have it to the right, I can just drop it. I don't have to have it. Right? So I moved that over 1 and this over 1. I moved over 2 spots to the right so I could pretend. I got to move it back 2 spots to the left to get my answer right. So this is 900ths, right? You might have a 0 and 900ths. Same thing here. I got to move it over 2 spots 16 hundredths, 2 spots. And again, it's not because I had 2 decimals, it's because I moved it over 2 spots. If I had 0.03 times 0.03, I have the 9 still, but I'm going over 2 spots for each of those. I got to go over 4 spots and fill in the egg carton, right? Okay, so remind yourself you're not counting the decimals, you're counting the numbers to the right of the decimal in your problem, okay, because that's the most common mistake. So this is 49 hundredths, 2 spots, 64 hundredths, 2 spots, 81 hundredths, 2 spots, 2 and 56 hundredths. Remember, the word and usually means that you're talking about a decimal or you're transitioning to a fraction for mixed numbers. All right, I'm going over 2 spots. 100th, 2 spots, 3 spots, fill in the egg carton. 1,000th, 1, 2, 3, 4 spots, fill in the egg carton. 1/10,000th, 1, 2, 3, 4, 5, 6. Yikes. Ran out of room, ran into my equal sign. All right, 1/1,000,000th. All right, how many days left in 2020? Well, today is the 26th. How many days in October? Well, you know the end of the month, right? Woohoo, Halloween, right? So to get to 31, I have 5 days, right? That's left in October. How many days in November? Well, you might not know this, but there's 30. And how many days in December? What's the last day of the year? New Year's Eve, December 31st. Add all these up. And we only have 66 days left in the year. Ooh, can't wait to get to 2021, huh? Get this 2020 behind us, right? By the way, there is a poem that helps you remember the days, how many days each month has, okay? And here's a joke for you while we're doing that. How many months have 28 days? They all do. Gotcha. They all do. Okay, 60 times 300 is 6 times 3, and I'm going to move it over 1, 2, 3 spots. 18,000. 7 times 300 is 21. Move it over 2 spots. 2,100. 60 times 20 is 6 times 2. Move it over twice. 7 times 20 is 140. 7 times 4 is 28. And 60 times 4 is 24. Move it over once. 240. So I have 18,000. I have 2,100. 1,200. 140. 240 and 28. Why did I give you such a hard problem? I give you a hard problem. I have to do the hard problem too. I should be smarter than that. 4, 5, 6, 7, and 8, 10, 11. Okay, yeah, that's 21,708. I'm going to estimate real quick just to see if that makes sense. That's too hard. Let's make that easy. When you estimate, you make it easy. 67 is too hard. Let's call that 70. And then 7 times 3 is 21. I moved it over 3 spots. 21,708. That's a pretty good estimate. Okay. All right. If I use the standard algorithm for 324 and 67, paper's cheap, guys. If you need more room, go take more room on another piece of paper. Right? 7 times 4 is 28. 14 and 6, 16. 14 and 2, thinking ahead. 7 times 3 is 21, plus 1, 22. Put a placeholder because that's really 60, not 6, right? Cross out your carry marks so you don't get confused. 24, carry the 2. 12 plus 2 is 14. And 6 times 3, 18, plus 1 is 19. Add 21,708. Boom, got it right, you guys. Good job. All right, 5 and 4 is 20. 8 times 4 is 32, but I got to move it over 1 spot. 3.2. 5 times 2 is 10, but I got to move it over one spot. That makes it 1. 5 times 3 is 15, but I got to move it over 2 spots. That's 15 hundredths. 8 times 2 is 16. Move it over 2 spots. And 8 times 3 is 24. And I'm moving over 3 spots. This is where people usually miss. They don't move it over 3 spots. They just think it goes in front of the 2. There's a 0 there, right? Now I got to line up the decimal. Where's the decimal in the 20? If you can't see it, it goes to the right. So I got 20. I'm going to go ahead and put 0.0, 1.0, 3.2, 0.16, 0.15, 0.024. And when I add decimals, I think it's helpful to add zeros so they all come out to the same column. Right, that's 3 spots past the decimal, and I did another color so you could see that. So I'm saying a 4 here. 15 and 2 is 17. Make that 4. Sometimes my 4s end up looking like 9s. Gotta write neater, huh? 3, 4, 5. And then I got 21, 24. When I estimate this, I say that's too hard. Let's make that a 4. That's too hard. That's almost 6. 4 times 6 is 24. 24.574. Yeah, it's pretty good. Now, let's go use the standard algorithm. 4.23 and 5.8. Pretend there's no decimal. 423 times 58. 16 and 2 is 18. 32 and 1 is 33. Put a placeholder because that's really a 50. Cross out those so don't get confused. 5 times 3 is 15. 10 and 1 is 11. And 20 and 1 is 21. I do these fast, but you can always pause and try to figure out what I did. You can send me a note and say, please slow down. How many numbers to the right of the decimal? I had to move it over twice in this one to get it so I can pretend, and once in this. That's 3 times total. I got to go over 3 times in my answer to get 25.534. Oh no, 25.574. 7, that's supposed to be 13. Carry the 1. 534, 534. Whew, glad I double checked. Could have lost some money on that one, huh? All right, good job, you guys. We will see you mañana on martes.